Alright, so if we wanted to draw a scatter plot and find the least square line in the correlation coefficient, I'm going to be using the TI-83 to do this example because I have it on emulator and I could just do it on my computer here. If you have the TI-36, just watch the tutorial video on how to do this stuff on there. It's a very similar process, so it shouldn't be too bad for you. But in any case, drawing a scatter plot here. I'm noticing all these values are positive, so I'm just going to stick to the first quadrant. When I'm setting up my scale here, my axis and my y-axis here, I want to make sure that my scale is set up such that I will be able to see all of the points here and that they're not all squished together. So I'm seeing that this goes from 1 to 7. So what I'm going to do is steps of 2. 2, 4, 6, 8. Actually, that's maybe a little too close. I can do farther apart than that. Let's go 2, 4, 6, 8. For the y's, it looks like the highest value is less than 4, so I'm just going to go up to 4. 1, 2, 3, 4. So when I set, then I can start plotting these. The point 1, point 3. So 1 is here. Point 3 is going to be roughly there. 3, 1.3 is going to be here or so. 5, 2.8. So 2 is there. 2.8 is going to be most of the, actually a little bit higher than that even. It's going to be most of the way to 3. Oops. 5, 2.8 is about there. And then 7, 3.3, 3 is there. 3.3 is probably up here. This is what we call a scatter plot. It's just taking the individual points and plotting them. Now, when you're doing this on the computer, you'll be given a multiple choice. You'll say which one of these looks like the scatter plot. Just kind of do it on your own and compare them. Or alternatively, look to see each individual point, make sure they're plotted correctly. Most likely you'll have, you may have one with positive, well, yeah, just verify that whatever multiple choice one they show matches up with what you would expect. Alright, so this says to, let's see, draw a scatter plot. That's done. Find the least square line in correlation coefficient. And this is where the calculator comes into play. So, what I'm going to do is hit on, wait for it to show up. I'm going to hit stat and edit to go in here. Now, I have data already in here. And what I'd like to do is to clear this out. So what I can do is I can select individual values down here, and I could hit delete and get rid of them one at a time. But that takes a little while, and it's just sitting there pressing a button. Alternatively, what I can do is I can go up to L2 and clear the whole list. What I do not want to do, though, is I do not want to hit delete at this point, because if I hit delete, it's going to go from L1 to L3. And, well, let me just show you what happens. If I hit delete, you can see it actually gets rid of the entire list, and now I can't put anything back in there. If you do that at any point, you're going to want to go into Stat and Setup Editor. So that now when I go back in there, my L2 is back. Instead, what I wanted to do is I wanted to go up here, again, don't hit delete, but instead hit clear. When you hit clear, you can see there, it did say L2 was equal to curly bracket with a bunch of stuff in there. Now it just says L2 is blank. And so when I hit enter, it actually clears out that entire list. So again, that was going up to the list name and hitting clear, enter, and that clears the entire list. And then I can go ahead and fill in what I want to fill in here. 1, 3, 5, 7 for my x coordinates, 0.3, 1.3, 2.8, and 3.3 for my y coordinates. Okay, I'll quit back out to the home, and I want to run linreg, which again was in stat, over to calc, and down to linreg. It's going to be using L1 and L2 by default, so I'll just leave it that way. It is possible to specify to use different lists, but I don't think we need to do that. So here we go. My slope, because this is linreg is ax plus b. You can see it says right there. So I know that a right here is my slope, and this is my y-intercept. So let me write those down. So my least square line, the equation for the least square line is y equals 0.525x minus 0.175. And my correlation coefficient, let me just bring this down so you can see it again. My r is my correlation coefficient. R squared, like I said, is used, but when we're talking about the correlation coefficient, we're talking specifically about r. So that's the one you want to write down here. R is 0.9844595, whatever. I'm just going to round that off. Let's call it 0.984. This is quite close to 1, so I would say that this is going to be a good fit. This is verified by, if you try to draw a line in here, it looks like that line right there is a pretty good description for what this stuff looks like. Also, you'll notice that my line looks like it would have had a negative y-intercept. If I was to continue my graph, it looks like it does have a negative y-intercept. So I'm actually fairly confident that everything is working correctly here. If I wanted to predict the y value when x is 6, well, we have an equation. I said x, I'm telling you a specific value for the x. We're looking for the y value, so it's just a matter of plugging it in here. Y equals 0.525 times 6 minus 0.175. And we can just plug that into the calculator. So let me pull it down here. 0.525 times 6 minus 0.175. We get 2.975. That would be our answer.